Okay, I'm going to talk about data cleaning and feature engineering, which are the underestimated parts of machine learning. And I'm going to talk about first of data cleaning shortly and the feature engineering and its methods. And I'm going to give you a simple and a few advanced examples of feature engineering. First of all, we have a pie chart shows that what goes into a successful model. As we can see, there are like data cleaning parts for 20% and a feature engineering parts for 25%. So we can say that data cleaning and the feature engineering steps are almost a half of the successful model. But why do we need this data cleaning and a feature engineering? Because we have to deal with the structural errors, handle missing data, and the filter observations. First of all, the feature engineering is about the creating new inputs features from the existing ones, and the data cleaning is a process of fixing or removing incorrect, corrupted, incorrect format, duplicate, or incomplete data, missing data within a data set. And the last thing is exploratory data analysis. It's an approach to analyze two data sets and summarize their main characteristics using mostly graphics and the data visualization methods. And how do you clean your data? The first question. So first step, we need to remove our duplicate and irrelevant observations. And then we need to fix some structural errors. And structural errors are when you measure or transfer your data and notice the strange naming conventions, typos, or incorrect capitalizations. These kind of problems can cause like mislabeled categories or classes. For example, you may have NA and the null both appear, but you should be analyzed as in the same category. And also we need to filter unwanted outliers. However, sometimes an outlier that will prove your theory you are working on. So remember that just because an outlier exists doesn't mean it's incorrect. So if an outlier proves that irrelevant for the analysis or is a mistake, so you can consider removing it. And also we need to handle missing data. So we can ignore missing data because of many algorithms will not accept missing values. So there are a couple of ways to deal with missing data we are going to see in our presentation. And we need to validate our data. Like we asked the question like, does the data make sense? Does the data follow the appreciated rules for its field? It's not what is is it a data quality issues? So what are the data quality? So the first thing is validity. It's a degree of the data conforms to defined business rules or constraints. Also, we have accuracy, like how close your data to the true values or real world values. And also completeness, it's about the missing data percentage in our data set. And also consistency. So you need to ensure your data is consistent within the same or similar or multiple data sets. And of course, uniformity. For example, if you have time column in your data set, you should note that all the data is in the same unit. For example, they should all in the like seconds or minutes. Otherwise, we should correct or change them, the units. So what are the benefits of data cleaning? So it's data cleaning is for like easy removal of errors when working on multiple data sources. And also it's good for ability to map the different functions and what your data is intended to do, and monitoring errors or better reporting to see where errors are coming from. And also we can making it easier to fix incorrect or corrupt data for the future applications. And also it's good for data cleaning. It's good for we make more efficient business practice and quicker decision making. And we have another pie chart. It's coming from the survey in Forbes. And we can say that the data scientists spend 60% of their time for cleaning and organizing data. It's this part. And if we had the collecting data sets, so we can see that the just collecting, cleaning, and organizing data sets take 80% of data scientists' time. So here's some kind of popular data cleaning tools: Integrate.io, OpenFI, Trifecta, and Talent. And also there are some Python libraries and already written Python codes for data cleaning in Jupyter Notebook. It's good for the Python users. And when we go to the feature engineering, it's the second thing in the slide. So we know that the raw data may contain different details like location, age, interest, time, and these details are features in our data set. So the task of creating a data set is to understand the useful features from the raw data and creating new features from the existing ones, which can impact on the results, and also manipulating the features such that they are model ready or enhance the data results. So these three topics are directly related to feature engineering. We can create a new data set, or we can create new features from the existing ones, or we can manipulate the features in feature engineering. For example, we can reduce the feature numbers with the feature selection, and it reduces our model training time, and also it could be improve our accuracy, like prediction or classification accuracy, and also it reduces the overfitting, because less redundant data means less opportunity to make decision based on noise. And here we are going to see some techniques of feature engineering. First one is encoding. So encoding is divided into two different types. The first one is one-hot encoding. It's a process of converting categorical data variables to binary ones. So we can use apple for 100 or chicken for 010, and we can give the details of the categories. And the label encoding is about converting labels into the numeric form. So we can use apple for one for apple, two for chicken, or if we have a movie data set like in here, so we can say 0 for comedy type of movies, 1 for horror, and 2 for romantic movie series. And second one is binning. It's also called bucketing. It's a opposite situation of encoding, and it is about converting numerical features into the categorical ones. So in this example, we have more than 70 or 80 different types of age. So we can put first 10 of them in here, and we can put the second 10 of them in here. So we are going to have only 8 different categorical features in our data sets. So the main motivation is make model more robust and prevent overfitting, but we need to be careful about the performance. So every time we may sacrifice some information inside of the continuous value. And normalization, so we can call it, the normalization is one of the scaling techniques. So in here we have raw data, price. We can scale it to from the 1 to 0. This is normal normalization, put all the values between 1 and 0. Or we can clip the data, the raw data. Like in this example, we only consider this part of data. We can call the other part as an outlier, or we can ignore it. Or we can use logarithmic scaling, which is good for some kind of data sets, not for all of them. Or we can use standardization. We can select the top and bottom values. And we know that the formula of the mathematical formula of the normalization. And here another example of about normalization is about probably scaling. So we can see that there's a bunch of outliers in the raw data sets. So the x-axis tells us the rooms per person. So we know that there's like 55 rooms per person. It's probably outlier data. So if we clip it between 0 and 4, so we can easily see the normal distribution or Gaussian distribution, and it's easily to ignore the outliers in here. The data will more make sense. Or we can combine the sparse classes. So in here, the y-axis shows us the materials of exterior walls. So we had wood siding, wood, and also wood shingle. So we can put all the wood related materials in the wood section. And also there are some less used another like concrete block, stucco, masonry, or asbestos. So we can put them into the other section. So instead of having 14 or 15 different classes, we are going to only need 8 or 7 classes in our data sets. So it can improve our accuracy and the time of training. And another important thing is missing values. So these are the most common problems when you try to prepare your data sets for machine learning algorithms. So the reasons for the missing values might be human errors or interruption in the data flow or privacy concerns. Whatever the reason is, the missing values affect the performance of the machine learning model. We know that. So there are a few methods. So we can simply drop those data points with missing values. It's good for when you have a huge data sets with less missing values, or we can use some kind of algorithms where the missing values are handled, or we can use data imputation techniques, which we are going to see in the next slides. So the simple ones first, for the numerical values. So we can use 0 for all the missing values, or we can use mode of the columns, which means the most used value in the numerical column, or we can use median, which is the middle value when you write down all the numerical values in the ascending or descending order, or we can basically use the mean of the column for the missing values. And for the categorical ones, so we can use most repeated value for the missing part, or we can create a newly named category, which implies the inputted data. And if you have a categorical features and a numerical features in your data set at the same time, so you can use complete case analysis, which is directly removes the rows that have missing data, or you can use arbitrary value imputation. It's the missing data is inputted with an arbitrary value that is not part of a data set or mean, mode, or median. Or we can use frequent category imputation. This is there's a high probability that missing data looks like the majority of the data. So here you can find a more info link in the slide. So to check the assumptions, advantages, or limitations of these three methods. And also you can see the Python codes, like how can you use this kind of imputation methods for your data. And also you can see when to use part as well. In addition to this, well, let me clean it. So there are many other imputation methods like KNN, random forest, discriminative deep learning. We can use GAN, or we can use different types of autoencoders for imputation as well. For the textual data, so we can use natural language processing to clean our text data, like removing non-alphanumeric variables, or we can remove the stock words, rare words, or common words. You can use tokenizing, enriching, and roots. And also you can use bag of words, different kinds of embeddings, or you can use LDAs as topic models to clean your textual data. And another important thing is outliers. There's two different ways to handling outliers. First one is using a standard deviation. So if a value has a distance to average higher than or lower than X times standard deviation, it can be assumed as an outlier. So let's assume that we have a data with the normal distribution. And we know that we have a mean at the middle, and we know that what is the standard deviation. So let's assume that the standard deviation, like X, let's assume that X equals to 2. So it means we have, here's a mean. So we use 2 standard deviation after mean and before mean. So we are going to deal with this kind of data, and we need to consider these 2 parts as an outlier. And at the same logic, so we can use percentages. In the Python example, they choose 95% and 5% as a top and bottom. So basically you can choose your 90% limit of your data and the 5% as a bottom limit. So these 2 parts under 5% and over 95% will be outlier for your machine learning algorithm. The key point is here to set the value depends on the distribution of your data. So this is all like your responsibility. So another most commonly used mathematical transformation is logarithm transformation. It helps to handle skewed data, and after transformation, the distribution becomes more approximate to normal. So for example, the most important thing is magnitude. in the logarithm transformation. For example, let's say that there's a difference between age 15 and 20, and it's not equal to age difference between 65 and 70. So for 5-year difference means a quarter life of a 20-year-old person, but the 5-year difference means only less than 10% for a 7-year-old people. So they're identical, but the 5-year difference in different ages, it affects different to our data set. So 5-year difference in young ages means higher magnitude difference. So the log transform normalizes the magnitude difference like that. And also it's good for decreases the effect of outliers due to the normalization of magnitude difference. And the model may become more robust after you use logarithm transformation. So the first example, so let's assume that we have a warehouse in the middle of the graph, and the blue dots are the stores where we can trade by making profit. And the yellow dots are stores where we don't want to do the business because of profit. So for the human perspective, it is easy to understand the graph, but it is not obvious for the machine learning algorithms. So here's what we can simply do using this equation, which simply converts Cartesian coordinates to polar coordinates. So we can make data available to machine learning algorithms. So we can easily separate them from the middle for the machine learning. And it is simple, but it shows the potential of proper feature engineering methods for the machine learning. And we talked about binding and the one-hot encoding. So we can see the example of binding in here. They use the Python examples. So we have a day column, which has 7 different features in it. So we can put all the column features in the weekend or weekday. In that way, we are going to have only 2 features in our data sets for the type of day. And also with the one-hot encoding, we can assign them 1, 0 for the weekends and 0, 1 for the weekdays. And for the imputation, so we see that we have a null value in here in the price column with the candidate data set. So if you remember the previous slides, one second, we can fill all the missing values with 0, which is not make sense for this kind of data sets, but it must be meaningful for the different kinds of data sets. Or we can use the mean of the columns, which is 7.94 for this case, or we can use medians or modes. But first, we need to write it down all the numbers, numerical values in ascending or descending order, and we can choose the median and put them into null missing values. Or we can choose the mode, which means the mostly used numerical data in that particular column. And here I'm gonna show you 3 different methods. It means like there are much more complex imputation methods. The first one is tsfresh. It's a Python package. It calculates the huge number of time series characteristics or features automatically. And we can see the number of peaks, median, mode, mean, minimum values, maximum values, or average values, or time reversal symmetry statistics. So this is the outcome of the tsfresh Python package. And also we can see the what goes background of the tsfresh. The second one is 1BM. This method interacts directly with the database row tables, and it slowly joins the tables and taking different paths of relationality. We can use relational and non-relational data with the 1BM. And also it was tested in the Kaggle competitions, and it outperformed the state of the art models. So here is the paper about the 1BM, and also you can see the archive link in the table. They have their own algorithm for 1BM. And this is the paper proposed, which proposed the 1BM in it. So you can basically search the name of the paper or click the link to reach the details of the 1BM method. And the last one is the autofit. Autofield helps to perform the linear production models with automated feature engineering and selection. So it allows you to select units of the input variables in order to avoid the construction of nonsensical features. So it has own autofeed regressor and autofeed classifier in the package. And it's similar to the interface of skitlearn models. So here's the paper the autofeed proposed. So you can see the archive link in here. And also I added another link for Python example. So you can just click it and see how they use autofeed for their own data sets. And this is all for the data cleaning and the data feature engineering for today.